Hello everybody, it's Tuesday the 9th of February and this is your maths lesson for today. You're going to need just paper and pencils and we are looking at comparing and ordering fractions greater than 1. You're not going to need your equipment, but you might want to draw some bar models, fraction bars to help you. But like last week's lessons and yesterday's lessons, your times tables are going to be very important for you in helping you solve these. So let's begin with our get ready questions. Questions coming up, pause the video and have a go, and then the answers will come afterwards. Let's see how we did. Well, first we had 2/9 is equal to the same as something 27th. Our numerator we don't know, but we know our denominator is 27. So using our times tables, what can we do to change 9 to 27? And the answer is we multiply by 3. 9 times 3 is 27. And whatever we do, we must do the same to the top. So 2 times 3, our 1 would be 6. 6 27ths is equal to 2/9. Question number 2, it says 7/9 and is something to 14/18. What do you notice about 7 and 14 and 9 and 18? Well, what we hopefully would have noticed that 7 times 2 is 14 and also 9 times 2 is 14. So we've actually multiplied both of those numbers, 7 and 9, by 2 and it's given us 14/18. So we should have put 14/18. We could have changed it to, and they are the same, equal to. And then the next one, question 3, it says the numerator is missing something 7ths is greater than 1, and that 1 means 1 whole. So as a fraction, as an improper fraction, a regular fraction, 7/7 is the same as a whole. So we've got to think what would be larger than 7/7 or 1 whole. So we would need to think 8/7 is larger than 7/7, which is a whole. So anything above 8, any integer greater than 7 would have been the right answer. And for the last question, we had 2/19 and we needed to work out what was the missing symbol here if we had 1/8. And what we could have done is seen what could we have changed. Could we have changed 8 into 19 by multiplying by something? Well, the answer is no. Could we have changed 1 to 2 by doing something? And the answer is yes, we could have multiplied that by 2 and changed it to 2/16. And which is larger, 2/19 or 2/16? And 2/19 is smaller than 2/16. So 1/8 is larger than 2/19. Now let's get ready with our main part of our lesson today. To begin with, we've got 11/7 and 9/7, and have a think, what symbol would you go there? What rule can you remember about improper fractions and mixed numbers, but also what can you remember when the denominators are the same? Pause the video and have a go. Let's have a look and see. Well, we could have remembered the rule: when the denominators are the same, the greater the numerator, the greater the fraction. We could have also drawn ourselves some fraction bars. We've got 1, 2, 3, 4, 5, 6, 7 parts to the fraction bar. So we've got our 7ths, and all of this fraction bar is shaded. So that's 7/7, 1 whole. Then we have 8/7, 9/7, 10/7, 11/7, which is our first fraction. Then we have 7/7 again and 2 more. So here we have our 9/7. And by looking, we can see there, looking at the second bars, that 11/7 is greater than 9/7. Now let's have a look at this one. Write greater than, less than, or equal to compare the fractions. We have 7/5 and 13/10. And I want you to think for 7 seconds, what would you do to these fractions to help you? Well, if you've got 7/5 and 13/10, we could see here we could change our denominators to the same by multiplying by 2. So we could change our fifths into tenths. Here we got 7/5. Here with the same size fraction bar we have 13/10, and we can see if we did it with a fraction bar, this is our extra space in our 7/5. So 7/5 is larger than 13/10. And again, if we remembered that rule, when the denominators are the same, the greater the numerator, the greater the fraction. So we could have multiplied by 2, and whatever we do to the bottom, we do the same to the top. We could have changed 7/5 to 14/10, and the greater the numerator, the greater the fraction when the denominators are the same. So 7/5 is greater than 13/10. Pause the video now and have a go at these questions, writing the right symbol to compare them. And remember, thinking about your times tables will be very important here. What do you know about your times tables? You might need to change one to the other. Look at the numerators, all the denominators. Pause the video and have a go. Let's have a look and see. For the first one, we could see that 12 and 24 are in the 12 times table. So we could have multiplied our 16/12 by 2 to change them to 24ths and change it to 32/24, making that larger when the numerators are the same. The greater when the denominators are the same, the greater the numerator, the greater the fraction. Let's look at our next one here. We had 26/21 and 10/7. We could have multiplied our 10/7 by 3 to change it to 30/21, and then we have 26/21, 30/21. When the denominators are the same, the greater the numerator, the greater the fraction, making 10/7 greater than 26/21. Then we had this last one here. We could have changed, we can see 4 and 44 are in the 4 times table. We could have multiplied by 4 to change our 6/4 to 66/44, making 89/44 greater. There was another way we could have looked at it though. If the numerator is greater than double the denominator, so double 44 is 88 and 89 is more than 88, that's greater than 2. And if it's less than double the denominator, that would work. Let's have a look at this one now. We've got 15/13 and 15/10. Here we have our 15/13 and here we have our 15/10. Have a little think, what symbol would we use here? Which is the greater fraction? And we should have put that symbol there. Remembering the rule, when the numerators are the same, the greater the denominator, the smaller the fraction. So remembering that rule now, when the numerators are the same, the greater the denominator, the smaller the fraction. What could we do for this one? Pause the video and have a go. How would you change one of those fractions? Can you see, are there the denominators in the same times tables, or are the numerators in the same times table? And if so, what could you multiply to make them the same? Pause the video and have a go. Let's have a look and see. Well, for our 9/5, we can see that 9 and 27 are in the 9 times table, and we could change our 9 to 27 by timesing by 3. And whatever we do to the top, we must do to the bottom. So we would multiply that, changing it to 27/15. And let's go back to our rule. When the numerators are the same, the greater the denominator, the smaller the fraction. So 27/24 is smaller than 9/5. So having a think now, using that rule, when the numerators are the same, the greater the denominator, the smaller the fraction, what would you do for that one? 8/7 and 4/5. What symbol would you put there? Pause the video and have a go. Let's have a look and see. We could have seen 5 and 7 are not in the same times tables, but 8 and 4 are in the same times tables, and we could have multiplied our 4/5 by 2 to change it to 8/10. And then remembered our rule, when the numerators are the same, the greater the denominator, the smaller the fraction. So 8/7 is larger than 4/5. And again, we could have remembered that rule. 8/7 is greater than 1. 4/5 is less than 1, so that would have helped us as well. Now let's have a look at this problem here. Rosie and Amir both baked cakes. They got a little hungry and ate part of a cake. Rosie says, I have 2 3/4 cakes left. So she's got 2 whole cakes and 3/4 of a cake left. Amir says, I have 2 whole cakes and 6/7 left. So he's got 2 whole cakes and 6/7 left. And the question is, who has the most cake left? Now to do this question, we're going to do it together. So we need to work out which symbol would we have. And the first thing we need to have a look at is what's the same about each mixed number. What do you notice is the same about each of those? I'll give you 5 seconds to have a think. Hopefully we spotted that both of those mixed numbers have a 2 in them, the 2 wholes. They're both the same. So if they're both the same, we don't need to concern ourselves about those. It's now looking at the 3/4 and the 6/7. And let's remember that rule. When the numerators are the same, the greater the denominator, the smaller the fraction. So could we change one of these fractions into the same numerator? Which of the numerator or the denominator could we change? And hopefully we spotted we can use our 3 times table, and we know 3 and 6 are in the 3 times table, and to change 3 into 6 we would multiply by 2, changing 3/4 to 6/8. Now we go back to our statement. When the numerators are the same, the greater the denominator, the smaller the fraction. So if the numerators are 6, 8 denominator is larger than 7, so that is the smaller fraction. 2 3/4 is smaller than 2 6/7, so that means Amir has the most cake left. Now that we've remembered those rules and we've looked at our times tables to help us, we've got some questions coming up. You're going to need to pause the video, have a look at the questions and see what you can do. Pause the video and have a go at these 3 questions. What symbol would you put? Draw and use the bar models to help you if you need to, or can you change them to their numerators and denominators so they are the same? Here are your answers. How did you do? Here's our next question. Again, it says write less than, greater than, or equal to compare the fractions. You can, if you want to, draw your fraction bar models, or it's looking at the denominators and the numerators and seeing, are they in the same times table? What could you do to change one to the other using your times tables knowledge? Pause the video and have a go. Here are your answers. Have a look and see how you did. Next we have this question here. It says Philip has 3 3/16 bottles of juice. So that means 3 whole bottles of juice and 1 bottle with 3/16 in it. Scott has 3 whole and 1/4 bottles of juice. So again, he has 3 whole bottles of juice and 1/4 of a bottle of juice. Who has more juice? So thinking when we did that before, if you want to, you can pause the video and go back to the question with the 2 children with the cakes to remind you how we did that. When you're ready, pause the video and then your answer will follow. Here is your answer, and we'll look and see what it should have been. Now, hopefully you said your answer was Scott has more juice. But here we can see how we could have checked. First of all, we would have spotted what is the same on both of those mixed fractions. So they both had 3 holes in them, so we needed to ignore those because they were the same and concentrated on our 3/16. What numbers could we have changed? Could we have changed the numerators, or could we have changed the denominators? Which of the denominators should we have spotted are in the same times tables? And hopefully we spotted that 4 and 16 are in the 4 times tables, so we could have changed 1/4 by multiplying by 4 and changed our quarter to 4/16. And remembering our rule, when the numerators are the same, when the denominators are the same, the larger the numerator, the larger the fraction. So 3 wholes and 3/16 is less than 3 wholes and 1/4. So Scott had more juice. Last question, and for this one it says Rosie's ribbon is 7/4 meters long. Teddy's ribbon is 7/8 meters long. And Rosie says our ribbons are the same length. Can you explain why Rosie is wrong? So you might want to do this as a drawing. You might want to show how you can convert one of them by using your times tables knowledge. But can you explain why she is wrong? Pause the video and have a go. So a way that we could have shown it is we could have used our numerators as the same, and when our numerators are the same, the greater the denominator, the greater the fraction. Or we could have changed our 7/4 into 14/8, and when our denominators are the same, the greater the denominator, the greater the fraction, the greater the numerator, And a way we could have explained it as well was the number of parts is the same, but the size of their parts is different. Rosie's ribbon was longer. That was quite a tricky one to finish with. But that is the end of our lesson for today. I haven't put a slide up for your maths frame, but you can go back and remind yourself and continue having a go at those previous games from Monday on maths frame to help you practice that skill. But well done for today, and hopefully speak to you tomorrow. See you later, everybody. Bye-bye.